Most software systems fail for one very boring reason. Not because of microservices, not because of monoliths, not because of agile. They fail because they're unpredictable. If I make a change and I can't reliably determine the impact of that change, then I can't safely evolve my system. And if I can't evolve my system, then it's already a legacy system. Today, I want to talk about something that almost nobody frames correctly: determinism. Because determinism is the bridge between it works on my machine and it works every time, everywhere. And if you care about continuous delivery, if you care about evolutionary architecture, and you should care about both, you should also care deeply about determinism. Hi, my name is Dave Farley and welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, why not get in touch with us in the comments below and hit like. Evolutionary architecture is about retaining the ability to change a system, but you can't evolve what you can't measure. You can't measure what you can't repeat, and you can't repeat something that isn't deterministic. If your tests are flaky, if your builds sometimes fail for reasons, if concurrency randomly breaks things, then your delivery pipeline stops being a real learning system. If the non-determinism is bad enough, it becomes merely release theatre rather than sensible release approach. Determinism is the prerequisite for trust, and so for engineering. Without it, your tests lie to you, your pipeline lies to you, your architecture rots quietly in the background. With it, you can run thousands of experiments per day, you can detect unintended consequences, you can move fast without gambling. That's an evolutionary capability. I'd like to pause there and say thanks to our sponsors. We're extremely fortunate to be sponsored by EquaExperts, Transfic and Octopus Deploy. Octopus make it easy to deliver software to Kubernetes, multi-cloud, on-prem infrastructure, and anywhere else. They automate the release, deployment, and operations of your software and AI workloads with a tool that can handle continuous delivery at scale. All of these companies, though, offer products and services that are very well aligned with the topics that we discuss here on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, click on the links in the description below and check them out. Let's start simple and think about time. All the physicists are now laughing in the corner. But in code, we can make time a simple, or at least a simpler problem. If your code calls datetime.now directly, you've just injected non-determinism into your system. The same input tomorrow produces a different output. That's not testable, that's not reproducible, that's not evolutionary. Instead, inject a clock. Pass time as data. Treat now as an input so that you can control the state of your system within the scope of the test. Now something magical happens. You can freeze time, fast forward it, and reproduce production bugs by replaying timestamps. You've turned the universe into a parameter, and that's a pretty powerful tool. Concurrency is where determinism goes to die. If thread scheduling decides the order of execution, your architecture is now probabilistic. It's subject to random race conditions, Heisenbugs, and you'll be familiar with the phrase, well, it works 99% of the time. That's not really engineering, that's roulette. There are effective ways to handle this. Actor models, single-threaded event loops, deterministic merge strategies, immutable state. When state doesn't mutate unpredictably, order stops mattering quite so much. When execution is structured as input, decision, event, you regain control. At LMAX, the system I worked on processed global financial trades, and each service was completely deterministic. Given the same starting state and the same sequence of events, we got exactly the same result every time. This is not about academic purity, it's about building better software and making evolutionary change safe. If you'd like to learn more about how to evolve better systems like this, check out my new free tutorial, Designed to Manage Complexity. There's a link to that in the description below. If you take one idea away from this video today, take this one. Separate the code that decides from the code that acts. This is the idea of a deterministic core. So we want pure logic, state in, decision out, no database interactions, no clock, no randomness, and then we have an imperative shell. This is where we deal with the messy part of the world. Talks to the database, talks to the network, talks to the clock, and executes side effects. This is really just another expression of ideas like separation of concerns, hexagonal architecture, and ports and adapters, but framed in a way that I think makes evolutionary capability even more obviously valuable. When the core is pure, you don't need mocks, you don't need frameworks, you don't need complex test scaffolding. You pass in state, you assert on output, and you can run thousands of tests in milliseconds. Those are your fitness functions at scale. And now your architecture can evolve safely, bit at a time. Non-determinism isn't only about threads or clocks though. It's about uncontrolled state space. If your system has 500 possible implicit states and you don't know which one you're in, you have entropy more than architecture. Instead, design narrower scopes, use explicit state machines, make boundaries between components serving different purposes clear, design components to reject invalid states. The narrower the scope, the more control you have over state. The more control you have over state, the more deterministic the system becomes. And the more deterministic it becomes, the more confidently you can be when you change it. This is evolutionary architecture in practice. This isn't just about code. This is about things like hermetic builds that are predictable, going to reproduce the same state of our system in terms of its implementation every time. Pinned dependencies, idempotent deployments. If applying your deployment twice changes the result, your infrastructure is non-deterministic, and now your production environment is a mystery wrapped in an enigma. Determinism isn't a coding trick, it's a systems property. Most organizations optimize for features, but the best organizations optimize for speed of learning. Deterministic systems shorten feedback loops, reduce cognitive load, make debugging reproducible. They enable aggressive experimentation. This is why continuous delivery works, not because of pipelines, but because of determinism. Increasing determinism is the target. The pipeline is really just the amplifier that helps us to see how close we are to it. Thank you for watching, and if you enjoy our content here on the Modern Software Engineering channel, why not consider supporting us by joining our Patreon community? There are many routes to doing that, and there are many options available to you. You can check them out with links in the description. And as ever, I'd like to say thank you to our existing patrons for their ongoing support. It's through your help that we're able to continue providing content like this. Thank you and bye-bye.